In the vast expanse of the world's oceans, a new titan has emerged, a symbol of 21st century naval power and a monumental leap in military technology. This is the story of the USS Gerald R. Ford, CVN-78, the lead ship of her class and the most advanced aircraft carrier ever built. More than just a warship, she is a floating fortress, a testament to innovation and the future of American sea power. For decades, the Nimitz-class carriers have been the undisputed kings of the sea. But as technology evolved and strategic demands shifted, the US Navy envisioned a successor. The Ford class was born from this vision, designed to meet the challenges of a new era. The goals were ambitious: increase combat capability, improve efficiency, and perhaps most importantly, reduce the immense cost of operating a carrier over its 50-year lifespan. This meant rethinking everything, from how aircraft are launched to how the ship is powered, all while requiring fewer sailors to operate. The Ford isn't just an upgrade, it's a complete reimagining of what an aircraft carrier can be. The journey from blueprint to blue water was a modern-day epic of engineering. Construction began in 2005 with the ceremonial first cut of steel. Over the next several years, a colossal puzzle of steel and technology took shape at Newport News Shipbuilding in Virginia. We are talking about a vessel displacing over 100,000 tons, assembled from massive, multi-hundred-ton sections called superlifts. It was a ballet of giant cranes and thousands of skilled workers. The keel was laid in 2009, a major milestone marking the formal start of the ship's physical construction. Finally, after years of tireless effort, the USS Gerald R. Ford was commissioned into the US Navy in 2017, officially beginning its service as the nation's newest and most formidable warship. At the heart of this behemoth lies a revolutionary power source. The USS Gerald R. Ford is powered by two A-1B nuclear reactors, the first new carrier reactor design in over 40 years. These power plants are a marvel of modern engineering, generating an incredible amount of electrical power, 3 times that of the previous Nimitz-class reactors. This immense energy output is the key that unlocks the Ford's most advanced capabilities. It powers everything from the sophisticated electronics to the groundbreaking launch systems. Crucially, this surplus power future-proofs the carrier, providing the capacity for next-generation systems like high-powered lasers and other directed energy weapons, ensuring the Ford remains at the cutting edge for its entire service life. Perhaps the most talked about innovation on the Ford is the Electromagnetic Aircraft Launch System, or EMALS. For over 60 years, carriers used steam catapults to launch aircraft, a powerful but mechanically complex and harsh system. EMALS changes the game completely. Instead of steam, it uses a powerful, precisely controlled electromagnetic field to smoothly accelerate a jet down the flight deck. Think of it like a giant, linear electric motor. This system is gentler on the airframes, which extends the life of multi-million-dollar aircraft. It can also be fine-tuned to launch a wider variety of aircraft, from heavy, fully loaded fighters to lighter, unmanned drones. This flexibility and efficiency are critical for increasing the ship's sortie generation rate, the number of missions it can launch in a day. What goes up must come down, and landing a high-speed jet on a moving runway at sea is one of the most dangerous tasks in aviation. To make this process safer and more efficient, the Ford is equipped with the Advanced Arresting Gear, or AAG. Replacing the old hydraulic arresting systems, AAG uses a combination of an energy-absorbing water twister and a digitally controlled electric motor to bring aircraft to a smooth, controlled stop. This precision significantly reduces the stress and shock on both the pilot and the aircraft. Just like EMALS, the AAG can be adjusted for different types of aircraft, improving safety and reducing wear and tear, which ultimately means the air wing is more ready and more capable. To dominate the modern battle space, a carrier must see everything, everywhere, all at once. The Ford accomplishes this with its revolutionary dual-band radar. This system is a fusion of 2 powerful radars into a single, integrated network. The S-band radar provides broad, long-range volume search capabilities, constantly scanning the skies for potential threats far over the horizon. The X-band radar, on the other hand, offers incredibly precise tracking, targeting, and illumination for guided missiles. By combining these two, the dual-band radar gives the ship's commanders an unprecedented level of situational awareness. It can track more targets, with greater accuracy, and in more challenging electronic environments than any previous system, making the Ford an all-seeing eye on the ocean. Every aspect of the USS Gerald R. Ford was scrutinized and redesigned for maximum operational tempo. The most visible change is the flight deck itself. The island superstructure, which houses the bridge and flight control, is smaller and positioned further aft than on Nimitz-class carriers. This seemingly simple change opens up a massive amount of valuable real estate on the flight deck, allowing for more efficient movement and staging of aircraft. Combined with redesigned weapons elevators that use electromagnetic motors to move ordnance faster and more safely from the magazines to the flight deck, the workflow is revolutionized. All these improvements work together to achieve a stunning 33% increase in the sortie generation rate, allowing the Ford to project more air power more quickly than any carrier in history. A warship is only as good as its crew. Recognizing this, the designers of the Ford class placed a strong emphasis on improving the quality of life for the sailors on board. While the ship is a technological marvel, it's also a home for thousands of men and women. The living spaces are designed to be more comfortable, and the ship offers better amenities than its predecessors. At the same time, the high degree of automation in systems like MLs, AAG, and ordnance handling means the ship can operate with a significantly smaller crew, hundreds fewer sailors than a Nimitz-class carrier. This reduction in manning not only lowers life cycle costs but also frees up sailors for other critical roles across the Navy, making the entire force more efficient. The USS Gerald R Ford is more than just steel and circuits. It is the culmination of decades of research, a bold investment in the future, and a powerful statement of American resolve. From its nuclear heart to its electromagnetic fingertips, every system is designed to ensure naval supremacy for the 21st century and beyond. As it sails the world's oceans, it carries not just an air wing of advanced fighters, but the legacy of American ingenuity and a clear message of strength and stability. The era of the Ford has begun, and with it, a new chapter in the history of sea power. Thanks for watching, and don't forget to like and subscribe for more stories of incredible engineering and technology.